this video, we'll introduce observational studies and designed experiments. We'll have two objectives for this lesson: to distinguish between an observational study and a designed experiment, and to explain the various types of observational studies. So we'll first start with distinguishing between an observational study and a designed experiment. That will probably be most of the first video, and then we'll do some more examples and talk about different types of observational studies. At the end of the total lesson, you should go back and ask yourself if you're able to do these objectives. If not, watch the corresponding video. So once our research question is developed, we should develop methods for obtaining the data that can be used to answer the questions. So we talked about in our last video, what is statistics? We want to start with a question, start with a possible answer, collect some data, try to measure it, and draw a conclusion and determine how reasonable our conclusion is. So here we're going to talk about methods for obtaining that data. Two methods for collecting data are observational studies and designed experiments. A little bit of terminology before we move on. We'll talk about what is a response variable and what is an explanatory variable. The variable that is associated with the effects of an observational study or designed experiment is called the response variable, whereas the variable that is associated to the cause of an observational study or designed experiment is called an explanatory variable. So let's look at an example to try to understand what we mean by cause and effect. To determine if radio frequencies from cell phones increase the risk of contracting brain tumors, whether or not brain cancer was contracted is the response variable, and the level of cell phone usage is the explanatory variable. So if our question is, does using cell phones cause brain tumors? The cause is the cell phones, and the effect is the brain cancer. So that's exactly what we say. Whether or not brain cancer was contracted is the response variable. How much you used your cell phone is the explanatory variable. Okay, now let's talk about observational studies versus designed experiments. An observational study will measure the value of a response variable, the effect, without attempting to influence the value of the explanatory variable, the cause, or the response variable. So in an observational study, we don't attempt to influence the values. That is, in an observational study, the researcher observes the behavior of individuals without trying to influence the outcome of the study. If the researcher assigns individuals in a study to a certain group, intentionally changes the value of an explanatory variable, and then records the value of the response variable for each group, this is called a designed experiment. So comparing between the two, in an observational study we simply observe, we don't influence anything. In an experiment, we try to influence the situation and see if I change the explanatory variable a little bit, how does my response variable change? A completely randomized experiment is a designed experiment where the researcher randomly assigns the roles to the research subjects. So these are types of designed experiments. We have completely random, or we could have a double-blind experiment, which is an experiment method used to ensure impartiality and avoid errors arising from bias. An experiment in which an observer tests the hypothesis by looking for changes brought on by alterations to a variable is called controlled experiment. In a controlled experiment, an independent variable, which is the explanatory variable, the cause variable, is the only factor that is allowed to be adjusted, and the dependent variable, the response variable, or the effect, is the factor that the independent variable will affect. A block design is a set, together with a family of subsets, whose members are chosen to satisfy some set of properties that are deemed useful. And a matched pairs design is a special case of a randomized block design. It can be used when the experiment has only 2 treatment conditions and subject can be grouped into pairs based on some blocking variable. Then within each pair, subjects are randomly assigned 2 different treatments. So I know that's a lot of information, but we'll try to parse through it in a couple of examples. One more thing we need to know, very important, is this idea of confounding. Confounding in a study occurs when the effects of 2 or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response variable may be due to some other variable or variables not accounted for in the study. So what we mean is there could be more than one cause for the same effect. There could be more than one reason why something happens. And so if you forget to consider all of the factors and you only look at one reason that something happens and you draw a conclusion, then you might have confounding. You might have basically an inaccurate result because you didn't consider all of the variables. So this brings us to the idea of a lurking variable. A lurking variable is an explanatory variable that was not considered in the study, but that affects the value of the response variable, which would lead to confounding. In addition, lurking variables are typically related to explanatory variables considered in the study. Okay, let's look at an example. Get married and gain weight. A researcher and her associate want to determine whether young couples who marry or cohabitate are more likely to gain weight than those who stay single. The researchers followed 8,000 men and women for 7 years as they matured from teens to young adults. When the study began, none of the participants were married or living with a romantic partner. By the end of the study, 14% of the participants were married and 16% were living with a romantic partner. The researchers found that married or cohabitating women gained on average 9 pounds more than single women, and married or cohabitating men gained on average 6 pounds more than single men. So the first question after we read this description is, why is this an observational study? So the question is telling us it is an observational study. Why? Well, if we look at what they did, they followed 8,000 men and women from the time when they were teenagers and they weren't married to the time when they were a little bit more grown up and some of them had gotten married. So this is an observational study because they did not attempt to influence the response variables or the explanatory variables. So because the researchers did not influence the explanatory or response variables, so they didn't ask people, hey, why don't you go get married now? Or why don't you stay single? They just let people do their thing. And they just watched what happened. They observed. Question B, what is the response variable in the study? What is the explanatory variable? So the response variable is the effect that we're trying to study. So let's say the response variable we want to know if people are gaining weight. And when do we want to know if they're gaining weight? Well, after getting married or cohabiting. So we could say marital status. So according to our study, the result might be weight gain and the cause might be getting married or staying single. C, identify some potential lurking variables in this study. Well, the researchers are only thinking about that people are either getting married or staying single. But what about the fact that people are getting older? If they start studying them when they're teenagers, and then they keep studying them through adulthood, well, maybe their metabolisms are leveling off as they're getting older. Or maybe they were in school, and when they were in school, they were taking physical education class, or they were playing on a sports team. But after graduating from high school, maybe after graduating from college and getting a job, they're sitting behind a desk, they're working in an office. So this has also changed. They might gain weight because of that. So we have these lurking variables that are leading to this confounding in our result. Question D says, can we conclude that getting married or cohabiting causes one to gain weight? We cannot conclude this because we didn't consider the lurking variables. So it might be true that getting married or cohabiting causes weight gain, but it might not be true. And we just don't know because we didn't consider enough of the factors. Let's look at one more example. The question is, should you have a cup of coffee to make you more alert when studying for a big test? A researcher is interested in studying the effect of caffeine, and he comes up with the following plan. The experiment will involve 100 volunteers, each of which will take a memory test 20 minutes after drinking cola. Some volunteers will be randomly assigned to drink caffeine-free cola, some to drink regular cola with caffeine, and others a mixture of the two, getting half caffeine, half non-caffeine. For each volunteer, a test score will be recorded based on the number of items recalled correctly in the memory test. The volunteers will not be told which type of cola they have been given, but the researcher who evaluates the results will prepare the cups of cola right on the spot, out of sight of the volunteers. What type of design is this experiment? So it's definitely not an observational study because we're definitely trying to influence the outcome. So it's an experiment. We have 100 volunteers. The volunteers will be randomly assigned into the categories. And the volunteers will not be told which category they're in. But the researcher who evaluates the results will prepare the cups. That means that he's going to know. So let's go back and look at the information we had about types of experiments. So a randomized experiment is a design experiment where the researcher randomly assigns roles. So it sounds like we've met that criterion. A double-blind experiment is an experiment in which both the participants and the researcher don't know. So we're not double blind because the researcher is mixing the cups, he knows. An experiment in which an observer tests the hypothesis by looking for changes brought on by alterations is a controlled experiment. We're definitely doing that. A block design is a set together with a family of subsets whose members are chosen to satisfy some of the properties. I don't believe we're doing block design because we're just randomly putting people in categories, and matched pairs is a type of block design, so we're not doing that either. So because we're just randomly assigning volunteers, because they're volunteers, that means we didn't choose them for any particular reason, which would be a block design if we chose particular types of people that we wanted. We're not doing that. So we're going to say that this is a controlled experiment, but it's just a randomized controlled experiment. So it's not double blind, and it's not a block design or a matched pairs design. But it's controlled because we're definitely attempting to influence the outcomes by giving people random, either caffeine-free or regular cola, and it's random because we're not putting particular people in particular categories for particular reasons. Okay, the explanatory variables are, so these are the causes, if you will. We can go back and look and we'll see that we have caffeine-free cola, regular cola, or a mixture of the two. And for response variables, we're administering a memory test after drinking the cola, and what does it say? A test score. The number of items recalled correctly will be recorded. So explanatory variables will be caffeine-free cola, regular cola, and half, a mixture of the two. The score of the memory test is the response variable. This is how we're measuring the effect of caffeine. Part D. The study finds that the group of students who drink regular cola has a significantly higher average test score than the group who drink caffeine-free. This implies A, the difference in the average test score between the regular cola group and the caffeine cola group is so small that it can be explained by chance. The difference in the average test score, B, the difference in the average test score between the regular and the caffeine-free is so small it cannot be explained by chance. C, the difference is so large it can be explained by chance. D, the difference is so large it cannot be explained by chance. So we would want to say the difference in the average test score between the regular cola group and the caffeine-free cola group is so large that it cannot be explained by chance, because they said significantly higher average test score. Okay, we'll do a couple more examples, but I want to go ahead and end this video so it doesn't get too long.